Hey pre-calc, I'm back for section 1.4, lesson 5, part 3 at this point. We're in the word problem bonanza like we were in the last two videos. I'm just moving right along. Number 77 is the one we're talking about here. It's kind of a physics application, braking distance. So basically the decision when you say, I gotta brake, and the distance between that decision and the time your car actually stops is given by this formula. So d is equal to the velocity plus the velocity squared over 20. They're probably oversimplifying it, but that's the basics of what's going on. V must be a miles an hour measurement, and d must be in feet. If they're not, then we have to do some switching of things around. So part A is really straightforward. They're saying let v be 55 miles an hour. It matches the units given to us in the directions. So it's kind of like, all right, plug 55 in here, 55 in there, square it, divide it by 20, approximate, and you get 206.25 feet. I don't know, I didn't indicate that it was exactly 206.25 feet, although I have a feeling that it very well might be. It probably is. All right, simple enough. Part B, if a driver decides to brake 120 feet from a stop sign, how fast can the car be going and still stop by the time it reaches the sign? All right, so we're looking for a velocity value in this case, which this is a little bit trickier. We've got a v squared and a v. This kind of has quadratic structure, which means we can get everybody on the same side of the equation, rearrange it so that it's a quadratic, and either use factoring or the quadratic formula. The thing I want to do first, and I don't know if it's helpful or more of a hindrance, I feel like if I multiply everybody by 20, then I can deal with coefficients that are kind of wonky. So if I multiply by 20, you get 0 on the left. It cross-cancels with the denominator's 20 on the right. So you just got v squared. It creates a 20 coefficient for the v. And then you've got a much bigger c value. Double 12 is 24 with another 0, It should be minus 2400. Just double checking here. Got it? Now I believe it's factorable. If you took 60 times 40, you get 24. If you get 60 times 40 is 2400. The difference between 60 and 40 is 20. So it should be factorable in this way. V plus 60, V minus 40 factors this polynomial. If you're kind of like, yeah, I would never factor it like that right away, plug it into the quadratic formula and you'll still get the same values, okay? So the values you'd get from the quadratic formula would be V plus 60 equals 0, which gives you negative 60, and then V minus 40 equals 0, which gives you positive 40. Now this is kind of tricky because some people could argue, well, velocity could have a different direction, but in this case, let's just think purely in terms of speed. All right, a negative 60 is not going to be viable in this case. Kind of like an extraneous solution. So we can be pretty confident that 40 miles per hour is the fastest you can be going if all you got is 120 feet of braking distance. So 40 miles per hour. Okay, that's number 77. 79. Price of a CD player. Oh wait, that's 81. My bad. Oh no. Okay, zooming out. Wow, it's a lot about distance in this case, yeah? All right, so if you're struggling to see this on the video, just go to your, it's in the page 52, 53, 50. It's 54, 55, 56 region in the textbook. So check this out. They even gave us a little visual to work with. An airplane flying north at 200 miles per hour. So this one's going 200 miles per hour. Passed over a certain point on the ground at 2 p.m. Another plane at the same altitude passed over the same point 30 minutes later, and it's flying at 400 miles per hour. They want to know, for part A on number 79, if T denotes the time in hours after 2:30 p.m., express the distance between the two planes. So this is kind of like a right angle that you have to be looking at a different perspective. And this distance between the planes right here should just keep increasing and increasing and increasing. So I'm going to say that this is kind of like, this is for sure a right triangle in which the hypotenuse is the distances between the two planes. So I'm going to redraw it so we can see it a little better. So we'll say this is the northbound plane. This is the eastbound plane. And this is going to be the distance between the two. So keep in mind, we've got two different things going on. We've got the distance that this plane travels. We've got the distance that this plane travels. And they are connected to the physics formula, distance equals rate times time. So when you think about it, distance equals rate 1 times some time value for this one. Yeah? Sorry, you cannot see that at all. I'm going to go back over here to this drawing. So this right here is sort of like our distance equals the 200 mile an hour rate times some time value. This distance right here, so I'll call this distance 1, this distance 2, is equal to the second rate, 400 miles an hour, times a different time value. They're different time values because they passed over the point at different spots. However, what they're doing here in the problem is they've kind of tidied it up for us. They said, let T denote the time in hours after 2:30 p.m. So what we're kind of doing is we're saying, let's let the eastbound plane kind of set the tone for what the time should be. We will let T be the time that E has, I'm sorry, not E, it's eastbound. This plane has traveled over that point P. Now the reason why that's significant is because this plane has also been traveling that exact same amount of time, except it has been traveling for a half hour longer since it flew over that point. So distance 1 is that first rate times time plus an extra half hour. And we have to do it in terms of hours because the speeds are in terms of mile per hour. All right, now before this gets too sloppy, let's tidy some things up. Let's call this distance now rate 1, 200, yeah? 200 times T plus a half. I'm sorry, you can't see that. Which, when you distribute it, gives you 200T plus half of 200. This expression now represents that distance on the right triangle. So I'm going to rewrite it as 200t plus 100. Yeah, we'll do the same thing on the bottom. This will be much easier. Distance will just equal 400t. All right, I don't think we've actually answered the question though. Express the distance between the airplanes in terms of t. So we saw this a little bit. Oh no, sorry, that was an AP Calc example. This whole idea of express the distance between the two planes in terms of t is saying, all right, what do we have to work with in our math arsenal? Like, what do we know about right triangles in which we could maybe use the fact that, I don't know, the Pythagorean theorem will give us a relationship between d squared, 200t plus 100 squared, and 400t squared. Basically, we can write an equation that has d's on one side, t's on the other, and that's exactly what they're asking us to do. Write an equation, d, in terms of t. Oh, sorry. I could have done that a little more succinctly. So here's the equation. A squared plus b squared equals c squared. That's the normal Pythagorean theorem. What we've got, though, is d squared equals 200t plus 100 squared, this whole thing squared, plus 400t squared. I'm going to write it over here so we've got some more room. At this point, you're going to have to expand the right-hand side. So this becomes a lot of large numbers. So this is 40,000 t squared plus 40,000 t plus 10,000. This is actually 400 squared, t squared. That ends up being 160,000 t squared. I just moved it from over here to down there. So d squared equals, well, okay, you got $200,000 t squared. Can we get rid of some of this stuff? This seems a little ridiculous. It's not equal to 0 though, so we can't just divide by both. We can't just divide both sides of the equation by 200,000 and be done with it. But here's what we can do. We can factor out 10,000 from each part. I'm going to divide out 10,000 from each part. That gives me 20t squared plus 4t plus 1. Here's the reason why I'm doing that. To get d by itself, we have to square root both sides. The square root of 10,000 is exactly 100. So we can make this a little more elegant by factoring 10,000 units out of this. Okay? Square rooting both sides means I square root this part, and then I can write the expression of the second part under the root. Yeah. So there's part A. Part B basically just says, at what time were the airplanes 500 miles apart? All we need to do there is take 500 and place it here in place of the D. I divided by 100 on both sides. I got 5 is equal to root 20t squared plus 4t plus 1. I can get rid of the root by squaring both sides. Okay. We got some room up here. You get 25 is equal to 20t squared plus 4t plus 1. If I subtract 25 from both sides, I get 20t squared plus 4t minus 24. If I solve that, plugging it into the quadratic formula, I get t equals 1 and negative 1.2. I'm eliminating that value and saying it's 1 hour after 2:30. At 3:30 p.m., that's when it's going to happen.